AP Calculus students, here is the second Chapter 2 test review worked out problems video. These are the problems you asked for. Please watch this video and then let me know today what questions you have. I will not be available for a while from about 4 o'clock until about 8 o'clock, but I'll be free before and free after. But I'll try to be super clear on this video so that you understand as much as possible. So on 2MCA10, which of the following statements, if true, can be used to conclude that f of 2 exists? Notice that f of 2 is a point. Okay, let's check out number 1. The limit as x approaches 2 of the function exists. That does not prove that there is a point right at f of 2. We have known all along that the limit can exist when the point does not. A point can exist when a limit does not, and they both can be the same. So for instance, just drawing you a picture here. Here is a picture of a graph where the limit as x approaches 2 exists, but the point does not. So number 1, no. Number 2, f is continuous at x equals 2. Yes, that does prove that the point at f of 2 exists because of the continuity test. The first part of 3 of the continuity test says that f of c exists. Right, and then it goes on to say the limit exists and then f of c equals the limit. So if it's continuous at x equals 2, by the continuity test, the first step, that point must exist. So yes. Number 3, f is differentiable at x equals 2. Yes, because we know differentiability, meaning the slope is the same from the left and the right of 2, implies continuity. And continuity implies the point exists. So the answer is 2 and 3 only. Next, 2MCA11. It's a piecewise function. For x less than or equal to 2, it's a line 3x plus 1. Then for x greater than 2, it's the line 5x minus 3. So you could draw yourself a picture of it. I don't know that is super necessary unless you absolutely need it, because it does take time to do that on the AP exam. Let's see what they want from us. Let f be the function defined above. Which of the following statements is true? Okay, let's start reading. F is neither continuous nor differentiable. Oh, okay. Well, they're asking us about continuity and differentiability in all of these problems, so I guess I'm going to have to work that out in my head. Okay, I'm going to draw a picture above just because I have some room here. Here is a picture of 2 lines at x equals 2. And they're not the ones that are shown. I just want to make a point here, right? That at x equals 2, these 2 lines join. Whoopsie daisy, one has to be less than 2. Let's go like that, there we go. So this line is for x less than 2. This line is for x greater than 2. Notice that this is a continuous, right, picture here, because these 2 lines do meet at that y value where x is 2. Here's a case where they do not, right? Here's a line and here's a line, right? Notice that these 2 lines where x equals 2 are not continuous because at this x they do not have the same y value. Okay, so let's first check out their continuity. I'm going to make myself a little chart right here. Okay, continuity, differentiability. All right, let's take a look. Continuous, that means where x equals 2, they would have the same y. So let's pop in those 2's for x and get the y's. That would be 6 plus 1 is 7, and when you put in a 2, that would be 10 minus 3 is 7. Oh, good. Okay, they are continuous. This piecewise function is continuous where x equals 2 because they do connect at that y value. Let's see if they're differentiable. that means that they have the same slope to the left and right of 2. Well, I know the slope of the line that is left of 2, it is 3, and the slope of the line that is to the right of x equals 2 is 5. These slopes are not the same, they are not differentiable. Okay, so let's take a look. Yes, continuous, no differentiable, and that would be F. Is continuous but not differentiable at x equals 2. Let's flip it over. 2MCA15. If f is the function defined by the 4th root of x, what's the derivative? All right. Well, I can see I'm going to need a little power rule here. So I am rewriting the function so that I can see the exponent in rational form. Went from radical to rational. I did not take the derivative yet. I'm going to do that now because now I can use the power rule. I'm going to bring the 1/4 out front and multiply it. And I'm going to reduce that exponent by 1. Notice I made my 1 4/4. 1/4 minus 4/4 is a negative 3/4. And that is the answer circled. On 2MCB1, notice that all the answers that are given are definitely from a calculator, right? And that's why it says calculator okay. Now there's a couple ways to do this problem. I'm going to do this the way I think you would do it, and it might be the easiest. Here's a G, and they are asking me for the x's where the derivative of G is 1/2. So they're giving me the value of a derivative, and they want the x where it happens. So one thing I could do is, it's easy for me to take the derivative of G, right, by the power rule, 4x cubed minus 9x squared minus 1. And I'm just going to set that equal to 1/2. There we go. On a y1, I'm going to put the function into my calculator, and this 1/2 is a y2. So is a y. I'm going to put that in a y2, and I'm going to set my window so I can see where these two graphs intersect and at what x it happens. Now, I just want you to also know that if this equation had been more difficult, or even if it hadn't, I could have in a y1 used my n derivative and typed in the function as I see it. I think that would be a good way to go, just in case you don't want to make a silly mistake. You see me do it, right, when I'm working on the board. So again, I'm going to put the derivative I found into the calculator, going to check it one more time, make sure I did it right, find where it equals 1/2. On a y1 instead, I could have used n derivative and put in the original function, but let's go ahead and put in what we wrote. Okay, on a y equals, oh look, it's right there. How about that? 4x cubed minus 9x squared minus 1, and I put in 0.5. Let's set the window. Because the y we're looking for is a 1/2, that's pretty small. I'm going to go from an x of, well, let's take a look at the x's we have. Geez, none are bigger than like, 4, and none are less than a negative 3. I'm going to go from an x of -4 to 4, because none of my answers are outside of those x's. My y minimum, right, I have a y of 1/2, so I'll just go from y's from -2 to 2. And let's hit graph, and let's see if we can see that intersection point. There we go. I can. The intersection point right here. I'm going to, please don't try to trace. You can't get close enough. Use second trace, intersection point. First curve, all I'm going to do, I'm going to get really close to that intersection point, though, to help my calculator out. Let's see. There we go. I'm going to get close to it. First curve, sure, that's one of the curves. Second curve, yep, that's the other curve of the intersection. Guess I don't have to. I'm super close to that intersection point. There we go. 2.3196 or 2.320 is the rounding I would use here. 2.320, and there is your answer. Okay, moving on. Let's take a look here. Where else did I put a star? 3MC3. There we go. Oh, I can see why you would ask this. This is a chain rule. So let f be the differentiable function h of x, right? 1 plus f with 3 to the x composed inside of it, and the whole expression is being squared. Which of the following gives the correct process for finding the derivative? I would handle this problem by taking the derivative myself and then comparing it to the answers. Notice I have an outside function of squaring. I have a middle function that's being squared of 1 plus f 3x, and on the inside of f, I do have a linear function 3x. So I am going to take the derivative of the outside function, then the middle, then the inside, one at a time, not changing anything else. Here I go. I'm going to put the derivative of h. The derivative of anything squared is 2 times anything, which is under my thumb. My anything is 1 plus f 3x. Notice I did not change anything on the inside. Times. Now I'm going to take the derivative of the middle function. The derivative of 1 is 0 plus the derivative of f of anything, right, is the derivative of f evaluated at the inside function, right? So I took the derivative of f evaluated at 3x. Notice I did not change the 3x. Finally, I will take the derivative of the innermost inside function, which is 3. Derivative of the squaring function, derivative of the inside function, middle function, derivative of the innermost function. And that is why the answer is D. 3MC4, what is the slope of the line tangent? You know that's a derivative, right? Notice how I'm marking things up. Do that on the AP exam. To this curve at the point 1, 2. Okay, you know we're going to take the derivative of both sides with respect to x, and you know that we are trying to find dy dx, or y prime. Okay, the derivative of y cubed, 3y squared, times y prime. Moving along, going to use, I'm going to keep my minus outside, going to use a product rule in the circle. The derivative of x is 1 times y squared, plus I'm going to keep my x and take the derivative of y squared, which is 2y times y prime. Good. The derivative of x cubed is plus 3x squared equals 0. Okay, this is pretty complicated. If they had asked me to get the y prime alone to what the y prime function is, I would do that. That's not what they asked me for. They asked me to evaluate y prime at the point 1, 2, where x is 1 and y is 2. Let's do that substitution left to right. I have 3 times 2 squared times y prime minus, in parentheses, this is a 2 squared plus 1, so I'm just not going to write that, times 2 times 2 times y prime plus, and then my x is 1, so this will just be 3 equals 0. Let's work this out. This is 12 y prime minus, let's see, this is a 4. I think I'll distribute here in here. There we go. 4, so minus 4. This is a 4y prime, so minus 4y prime. Plus 3 equals 0. We can get our y primes together. 12y prime minus 4y primes is 8y prime. minus 4 plus 3 is a negative 1 equals 0. And when I add a 1 and divide by 8, right? So add a 1, divide by 8, I get y prime is 1/8. Add a 1, divide by 8. There we go. Let me know if you have more questions there. Next. Oh, I can see why you would ask this. They didn't ask a question like this in the book, but you're definitely used to related rates. A rectangle with a width of W inches and a height of H inches. Well, let's go ahead and do that. Width and height. There we go. Where the width is twice the height, oh, then I'm kind of out of proportion. I'm going to help myself, okay? The width is 2 times the height. Okay, so here's what I'm going to do. You know what? I'm just going to leave it like this. The width equals 2 times the height. Right? We're okay. There we go. Both W and H are functions of time measured in seconds. In other words, this rectangle is either growing or getting smaller. If A represents the area of a rectangle, looks like we better write that. Area equals base times height for a rectangle. So my area is 2h times h, which is 2h squared. So there is my area of the rectangle. Which of the following gives the rate of change of A? They're asking for dA dt. Plus I know that, right? That's what they're giving me here, dA dt, with respect to time. Okay, let's take the derivative of both sides with respect to time. There we go. And we get dA dt equals, I'm going to bring the 2 out front and multiply it by the 2 that's already there. And that gives me 4h, because I reduced the exponent by 1, dH dt. And let's see, we said that that is the area, so that must be inches squared, and it's changing per time, which is seconds. So let's see. So I'm looking for dA dt is a 4h. Why is it not the first one? Because inches per second is a length, right? Is it a length per time, right? And this is a rate of change at area, so I need an area, a squared per time, right? So so is it 4h dH dt? Oh, I see up here they forgot their dH dt. But it's not inches per second, it's inches squared per second. So this is what we wrote, right? So this would either be the answer here or here. And when you compare, you're like, oh, well, this one is inches per second, and this was an inches squared per second. Well, we said it's an area, right? That's an area in the numerator and a time in the denominator, so that's what I have to show in my units, and that's why the answer is the last one. Let's see, last problem. You will have problems like this in the free response section. So this is pretty complicated looking, right? Kind of scary. So the depth of a river at a certain point is modeled by this function W above, where WT is measured in feet and time is measured in hours. So it's almost like they're going up or down a river and they're measuring the depth at those different points according to time. So from 0 to 6 hours, anytime you put the time into this trigonometric function, it gives you the depth. From 6 to 10, obviously the river has changed, and between 6 and 10 hours, the depth is given by this expression where if you put the time in, it will give you the depth. Now they are asking for the derivative of the function at 8. So you may feel like, but you're like, well, there's 2 different functions. Well, not at 8, right? At 8, this is the only function that is happening at a time at 8, right? 8 is in between 6 and 10. This function that I did not circle is not occurring at a time at 8. It only occurs from 0 to 6. So I'm really just taking the derivative of this function and evaluating it at 8. So let's go ahead and take the derivative of the circled function, right? And then we'll put in the 8. Okay, the derivative of 10 is 0. I'm going to bring my constant of a negative 1/5. I have a squaring function with a t minus 6 function on the inside. I'm going to first take the derivative of anything squared. That would be 2 times anything to the first power. Then I'm going to take the derivative of the inside function. Notice it just happens to be 1, so I don't have to put times 1. So I'm going to evaluate this at 8. There we go. So let's see, when I put an 8 in, 8 minus 6 is 2. 2 times 2 is 4. Times a negative 1, we get a negative 4/5. And it does say using correct units, very important. Okay, this was depth in feet per, and the time was hours, right? Because it was a rate of change of the depth over time. So that is what I put for the units. The rate of change of the depth per time. And negative 4/5. And I believe that does it for us. Let me know if you have any questions, and have a great day.